All right, now we're going to get to conditional statements. So conditional statements are if-then statements. Um, so they're connecting two propositions. So remember, propositions are statements with if-then. So the proposition that follows if is known as the hypothesis. And the proposition that follows then is called the conclusion. So going down here, we have a conditional statement. Shocking. I'm using Louis and Flash. So Louis is a dog. That's following the if. So this is my hypothesis. Then Flash is a cat. So Flash is a cat is my conclusion. All right, this is going to be a little strange in the beginning, but I'll give us a nice example. So if the hypothesis is true, we would expect to follow through with the conclusion. So what I'm saying there is whatever your conclusion is, that will help us determine the truth value of the entire statement, the if-then statement, the conditional statement. We're going to get to an example in a moment. If the hypothesis is false, so this is the part that many students, including myself, struggle with. If the hypothesis is false, then we have not said anything about what we'll do. So I'm going to get there in a moment. Again, it's a little strange. So if your hypothesis is false, we're kind of like living in a world we don't have enough information about. So we don't really understand how to determine the truth value of the if-then statement. So let's get to this example. So a conditional proposition has two parts, and each can be true or false. The entire statement is then either true or false. So here's my conditional statement. If Louis is a dog, so Louis is a dog is my P, and Flash is a cat is my Q. All right. So if I claim my hypothesis is true, so Louis is a dog. All right. I'm going to claim that's true. And then I'm going to say, okay, Flash is a cat. That's also true. So if Louis is a dog, which is true, and then Flash is a cat is also true, then this whole statement is true. And I also want to show you that there's some symbols. I could say P, if P, then Q. This is also a symbol for that. So you might see that on my open math. Now I'm going to say my hypothesis is still true. So if Louis is a dog, but then I'm going to claim my conclusion's false. So I'm going to say if Louis is a dog, then Flash is not a cat. Well, that whole statement can't be true, right? Because we know Flash is a cat. So that's why this statement is false. And that's what this is getting to up here, where it says if the hypothesis is true, which are these two examples, then we can expect to follow through with the conclusion. So what that is saying is, okay, if your conclusion's true, your whole statement's true. If your conclusion's false, your whole statement's false. Now I'm going to claim my hypothesis is false. So now if Louis is not a dog, then Flash is a cat. Again, this is the bizarre thing. And what I'm saying here is, but I know Louis is a dog. So I'm like really confused. I don't have enough information to determine anything. And again, this is just by convention with mathematics. The whole statement is true. Now, if my hypothesis is false and my conclusion is false, again, these two options, it's just not true, right? Like Louis is a dog. So because you don't have any information to prove otherwise, it's true. So what I'm getting at here is when your hypothesis is false, no matter what, your whole if-then statement will be true. But if your hypothesis is true, then it's going to determine your truth statement is dependent on your conclusion, truth value. So again, this piece is always a little strange, so please reach out if you have questions. So what we're going to do here, forgive me, is that now we're going to talk about some other ideas of how to write these conditional statements. All right. So the original conditional statement says, if Louis is a dog, then Flash is a cat. Well, your converse, what that says is, if Flash is a cat, forgive me, then Louis is a dog. So what happened here is, remember, this is saying P, if P, then Q. That's what my original conditional statement says. If I'm using these symbols, what I'm now saying is, if Q, then P. So that's what the converse does. It just flips it. Okay. So it might change your truth value. So if Flash is a cat, that is true. Then Louis is a dog, that is true. So that's still true. Now the inverse says, if Louis is not a dog, then Flash is, forgive me, not a cat. And so if I'm going to use those symbols, what that's saying is, and there's not means you're going to just give this like little tilde sign, not P, if not P, then not Q. So it's just negating the two conditionals, or sorry, two propositions. And if we're going to go back to that truth value, if Louis is not a dog, again, I'm living in that world I don't understand, then Flash is not a cat. Yeah, that's true, right? They're both not going to be, yeah, it just works out. That's a terrible way of me explaining that. Um, Now the contrapositive is the combination of these two. So I'm going to say, if Flash is not a cat, then Louis is not a dog. And so what I'm saying there with my symbols is, if, or sorry, not Q, if not Q, then, that arrow means then, not P. And what we're learning in this class is just the definitions of converse, inverse, contrapositive. If you got more into logic, we would do like a truth table with these. And it actually used to be part of our curriculum, but I'm really happy we got rid of it because it is pretty challenging. I mean, I think this alone can be pretty confusing right here. So we're just going to, it's a statewide thing. We're just going to stop the curriculum right there. But if you want to reach out and ask any questions, please do.